Alright, this is going to be my first video on a new design. I recently started making a video for my telescoping design that all strewn across over there, that I prototyped for a telescoping tubing mechanism. I was inspired just to start documenting stuff. I read an article about a graduate from Olin College of Engineering that really inspired me, where he said the importance of documenting your progress. So I'm trying to do that as much as possible. A, so that I can don't forget. A, so that I don't forget anything. B, so that I can go back and I can review my work later. I can see what I did well, see where I could improve, and be able to see what I thought, how I thought, where I was at in the entire process. And also, if anybody asks about the mechanism, I can show them how I got to the point that I was at, given that these would exist in some tangible capacity. I'm saying this now because I didn't say it in my first couple of videos, but I thought it would be good in case I looked back and I said, okay, why did I start doing this? And that would be the reason. So I'm going to introduce today a scissor mechanism. Now, why am I designing this? So scissor mechanisms are fairly common in FRC play. Not that they're highly used, but they're very known about. They have a tendency for not being that stable, which is one of the main concerns for a lot of teams, which I have this little thing there. I'll explain in a minute. So upon researching various designs, that was a design I saw for FTC I wanted to check out, but I think I found something better. And this isn't a grab from other people design. I don't know if anybody has ever done this, but most of this came from my head. The tensioner belt, and I'm going to think about doing a takeoff pulley, are things that I saw on other teams. I'm going to try to do it differently, serve the purpose that we want to serve. So what I have right here is that I have a pneumatic piston, and excuse my drawing, doesn't look like a pneumatic piston, and you have obviously a scissor lift, fairly basic. This would be aluminum tubing that would be bolted right in those spots on the corners, so that way when you push these two ends together, this whole thing would extend. When you pull them apart, it would retract. That's a scissor lift. So each of these aluminum tubings, and I say carts on track, that's my initial thought. What I think I'm going to do now is have the aluminum tubing with a hole drilled through it, and make the bottom of it curved so that it doesn't rub up against the bottom of the ground, and actually use angle iron on either side of the tubing to create a little bit of a lane and cut horizontal slots in the angle iron on the part that is facing, or I'll just get a little bit of an illustration, I guess, or I guess if I just have the angle iron, it's like that piece. It's just an L shape on this side. And that's I would cut a slot, and using bolts in that track and on this side as well, I would have those be able to slide independently, and those this pneumatic piston would slide in and out, and would either attach to that aluminum tubing or just push it independently. I believe I would, for what I was thinking about, it would have to attach somehow, and whether that attaches to another part that slides in that's attached to that, I can determine later. But when the piston pushes that way, it extends the mechanism, pushes these two parts together. Actually, this would probably, now that I'm thinking about it, this would be static. That would stay there. This would slide, and you just have to mount it a little bit off center. That way, when a little bit off center. That way, when it contracts, it's fully center, and this would slide. So you take this and you push it that way, and it extends, and you pull it back, and it retracts. Now, the main problem with this issue, I should go over actually. The purpose is to be able to climb for the 2016 FRC game at the end of the game. If anybody is curious as to what that is, who doesn't know what it is, it's fairly easy to look up. So I would just suggest doing that. Anyway, is that this mechanism really wouldn't be that strong, especially with pneumatics. Usually do things just moving the metal. They don't pull that much weight all the time. And I don't have an extensive knowledge of pneumatics. I'm planning to learn it for this project a little bit better. I have someone on my team who's looked into it more, and I'll learn from him. It might not be able to pull the robot up. So what I've been thinking about doing is actually have this hook at the top of the mechanism, have a bit of a pull across, and I'll actually draw this right now. So have a bit of a pull across. So anything like that at the top. Now in that there will be a little bit of a divot. All right, a little divot, and that's where the hook is going to sit. And it'll sit there. It's not going to be locked in there by any means. Maybe it'll have like some weak lock so that it won't fall out. Basically, but the idea is that this hook will then be attached to this tensioner cable that's separate from the lift mechanism that ties down to a motor and a gearbox with a pulley, which is sort of what I have for the telescope mechanism. I probably wouldn't use a tough box nano like I did for that, because for this purpose it's carrying a heavy weight. We'd probably want more torque rather than RPMs. We'll see how that works. But this would pull. This is variable to change. I threw this together in 2 seconds. This would pull. So what you do is you extend the mechanism up to the top of the tower, get the hook on, pull the mechanism back down, and here you have now the bar on the tower, right? And then you have a hook onto it, and your mechanism has been pulled back into your robot. This is the telescope mechanism laying in here, and now you have your hook up here that's attached to a tensioner cable that's being pulled right there, in a coil right there, and now you have a hook, tensioner cable pulling your robot up. And at that point, somewhat like what the Robonauts have, except they just shoot their hook up, which is quite a feat. But yeah, that would be the design. I hope to actually incorporate this. This is something that, while the telescoping design is planning for the future, maybe predicting the next game, but then also having the design on hold for anybody who needs it. This is a project we're actually working on as a team. And right now the design group is just me and the mechanical lead, Annabelle, and I've just gone off and I've designed this. I'm going to show this to her and see where we get. I'm going to work on prototyping it, but I wanted to make a video on the general concept idea. This video is getting kind of long, so I will stop there.